of our Cisco's SD-WAN training. Hope you all are doing good. And let's get started with this video. In the previous session, we discussed about the management plane of Cisco's SD-WAN solution. And in this session, we will be speaking about the control plane. So let's get started with the discussions of control plane. Like we discussed that the component that actually manages the vManager, that actually manages the management plane in the SD-WAN solution is vManager, which is a completely virtual appliance. Similarly, the component which manages the control plane.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
In the SD-WAN solution is vSmart. And vSmart is also a complete virtual appliance. You do not need to purchase it. The physical appliance cannot be purchased. It is just an operating system that you purchase along with the solution itself, and that can provide you the ability to deploy vSmart in your SD-WAN solution. So previously we learned how the control plane has been separated from the data plane in the traditional sense, and the component that provides the control plane functionality in the Cisco's SD-WAN solution is vSmart. So vSmart kind of acts as a brain of the SD-WAN fabric, right? And if you speak about the capacity of vSmart, then when you deploy one vSmart, then one vSmart can manage up to 5,400 control connections. Now understand the difference, okay? In the previous video, I said that the vManager can manage up to 2,000 WAN edge devices, okay? And in this session, I'm saying that the one vSmart can manage up to 5,400 control connections. I'm not saying that it can manage 5,400 WAN edge devices. So what's the difference? If you have a vSmart being deployed and you also have a vManager being deployed, and both of which are kind of exposed to the transports, just like how we draw the diagram in the previous video. And we have WAN edge number 1 and WAN edge number 2. 1 again being connected to both the transports, 2 also being connected to both the transport. So if that's kind of the deployment that we have, then your WAN edge number 1 will create 2 DTLS tunnels with vSmart. One being via iNet, the other one being via MPLS. But that is not something which is allowed with the connections that we form, that our WAN edges form with vManager, right? Your WAN edges, irrespective of how many transports you have, it will only form one DTLS tunnel with vManager. Now that can be via iNet or that can be via MPLS, depending on what tunnel comes up first, right? But if you have 3 transports, like let's say you also have 3G and LTE, to which your vSmart and vManager is connected, to which your WAN edge 1 and WAN edge 2 is connected. So again, with WAN edge to vManager, 1 tunnel, but from WAN edge to vSmart, that's gonna be 1, 2, and then 3 tunnels. So 3 tunnels from WAN edge 1, 3 tunnels from WAN edge 2. Every tunnel that you form is assumed as a control connections, and your WAN edge can have and your vSmart can have around 5,400 control connections being established with WAN edges. So with that sense, if you have one WAN edge, okay, or if you have a WAN edge that has only single transport, then you can say that you can create around 5,400 control connections with 5,400 WAN edges via vSmart. If you have every WAN edge in your production environment that has 2 transports, then the number 5,400 instantly gets divided by 2, and totally your one vSmart can manage around 2,800 2700 WAN edges. And if every WAN edge of yours have around 3 transports that it connects to, then it will only be able to manage around 1800 WAN edges, right? 2 transports, and I'll say 3 transports. That's how the number changes in terms of how many WAN edges can be managed by single vSmart. And your vSmart can be deployed in cluster mode also, right? So you can create one cluster can be of minimum 2 vSmarts, and the number can go up to 20 vSmarts. And there is no concept of using the number of vSmarts in odd numbers. You can keep 1, or you can keep it 2, 3, 4, 5, 6, 7, whatever you want. Up to 20 vSmarts can be deployed in order to cluster your number of vSmarts that you have. So now over the DTLS tunnels that your vSmart maintains, right? These are DTLS tunnels. And over these particular DTLS tunnels, the protocol that vSmart uses in order to communicate all the important information, right? That is OMP. So OMP is kind of used. Now, when you think about it, the vSmart uses these DTLS tunnels right? Number one thing that it does is route distribution. Second is configuration management. What configuration gets pushed, what configuration gets revoked. Third one is the key negotiation. Fourth one is policy dispersal. Right? And certain other things. All these features, be it the route distribution, which means Vantage 1 has some backend route that needs to be advertised out to Vantage number 2, then the Vantages are not going to directly send these route updates to each other. The Vantage will give those route updates to vSmart. vSmart will propagate the update further to other Vantages. So in a traditional sense, the vSmart kind of acts as a BGP route reflector, right? Then the configuration management also is done by vSmart. So when I told you in the previous session that the admin machine will kind of interact with vManager to specify the intent of the configuration that needs to be pushed on your Vanages, the vManager does not directly sends the configuration on Vantage 1. No, it first tells vSmart, then vSmart sends the configuration out to the Vantage. That's how it works. Okay, so vManager never directly pushes the config onto the Vantage. It is done via vSmart. Then the key negotiation, like we discussed in the data plane section, that every Vantage will create a data plane connectivity with the other Vanages, which means the IPsec tunnels. But to form up the IPsec tunnels, the public-private keys in the SD-WAN fabric will be distributed via vSmart. So Vantage will give all the necessary parameters and the key information to vSmart. vSmart will give it to Vantage too. They do not directly exchange with each other. Then policy dispersal, if you want to push any configuration of policy, you push it on vSmart, the effects will be seen on Vantage behaviors and so. So all these functions, it kind of acts as a brain, okay, for the entire SD-WAN fabric. So since the control plane is responsible for encryption of the fabric, the route distribution of the fabric, the key negotiation, policy dispersal and everything, having vSmart is quite important. But what if the vSmart goes down? If the vSmart goes down, does it mean that your Vanages can still talk to each other? Well, that's not the case. So if there is a situation where the control connectivity was established between the WAN edges and vSmart, but for some reason it went down. Maybe the links of vSmart went down, maybe the links of WAN edge went down, or the underlay connectivity is disturbed for some reason. So in that case, if there is such situation, the data plane connectivity will continue to flow. So there is a concept of something called OMP, graceful shutdown. What does this OMP graceful shutdown do? The OMP graceful shutdown will keep the last received routing table active for the default timer of 12 hours. Okay, so your advantages will keep on using the last received routing update, and it will try to forward traffic between your necessary IPsec tunnels, which are already established, for 12 hours. After 12 hours, it will flush the routing table if the vSmart doesn't comes up in that time. And this timer can also be changed up to 7 days. But there are consequences. You should be careful enough while you change that particular time. Okay. So when the control connectivity is re-established, after the, let's say after 2 hours, there was a manual intervention and it was troubleshooted and the vSmart is up again. So after the control connectivity of the vSmart is re-established, then the manages will be updated with any policy changes that were made during that particular timeout, or any route advertisement that was done during that particular timeout or so. So vSmart will again send a fresh routing table out onto WAN edges. The WAN edges will flush the existing routing tables that they maintained or cached, and new routing table will be installed. This is a process in which you might see a brief outage to the data plane, right, when this particular change occurs, but it does not disturb the fabric that much, right? Because when the control connectivity is restored, the routing table is flushed and newly received routing table will be installed. But for redundancy purposes, the best practice dictates that you have at least two vSmarts geographically dispersed, and vSmart should have an identical policy configuration to ensure that network stability is there. But if these, because if these configurations that are present in the high availability mode, that vSmart 1 is configured with some policies, vSmart 2 is configured with some other policies, and they are not identical, then in that particular cases, you risk of having suboptimal routing issues among themselves, and the exchange of control and routing information can also be treated in a malfunctioned way, right? So you should basically see how you need to, or take care of implementing high availability. Although there are other factors that needs to be considered when you speak of redundancy in your controllers. We'll speak about that in the upcoming sessions. But right now, that's how your control plane generally functions. Okay. And I hope that gives you a sense of how your control plane works. And yeah, that's all. So that's been the bit about my control plane discussion. I hope you understand how vSmart work. I hope you enjoyed the content as well. Thank you so much for watching. And the next one, I will be speaking about the orchestration plane, which is the last component of the SD-WAN fabric. Thank you so much for watching. Take care, and I'll see you in the next one. Bye-bye.